Okay, so today we're going to continue with section 7. It's going to be quadratic inequalities. So again, remember a quadratic inequality or a quadratic equation has an x squared term. Now, these are a little different, so we've got to consider both the positive and the negative when we're solving these. So some other symbols that you're also going to be using in your interval notation are the union and the intersection of sets. So when you see this U symbol, this is going to be, you're going to basically list everything. It's a combination of different parts of the inequality. Then the intersection would be what's in common. So generally when you're first introduced to these symbols, you might say you have set A, and it's consisting of 1, 2, 3, 4. Set B. It's going to be more with the interval notation, but just to give you a brief introduction of what these symbols mean. If I were to say union set A with set B, that would mean I would list everything that's in both and don't repeat. So notice how I listed 1, 2, 3, 4, and then notice 2 and 4 in set B were already listed, so I just had to include the 6. When you intersect two sets, same two sets, I'm just listing the members that are in common. So the ones that you see in both are the 2 and the 4. So the intersection of those two sets would be that. So we're going to intersect and union some of our solutions when we get to this. Yes. Yes. Now, when we're solving the quadratic inequalities, we're going to follow these 3 steps. So my first step is to solve the corresponding quadratic equation. I am going to turn it into an equation. I'm going to take away the inequality, put in an equal sign, and then factor it or solve it. Then the second step is I'm going to identify the intervals that are going to be broken apart based on my solutions. Then after I break it into the intervals, then I have to find a test value from each interval to determine which ones are going to form my solution set. Yes?
Do we have to check like a test on each one of them?
Yes. Okay. Really, all you're going to do is it's going to have a pattern. So if the first interval fails, then the next one works, then the next one fails. So it'll be like X, or check, X. You're going to see what I'm talking about. The easiest test point to try to test is 0. If you plug a 0 back into your original equation, if it works, then that interval where 0 occurs gets the check mark. Okay? Then the ones on either side, you're going to cross off. But you're going to see it as I do examples. If 0 happens to be one of the answers or the cutoff for your interval, you can't use 0. You'd have to pick another number. Okay, and I'm going to explain. But these are the 3 steps that I'm going to follow when I solve these. So my first example here. Now, let me go back. So here's my first example. So notice I've written step 1. It says find the values of x that satisfy the equation. Notice I've turned the inequality symbol into an equal sign, and now I have to solve this for x. If it can be factored, factoring is going to be the fastest way. So let me go ahead and factor this. What are the factors of negative 12 that give me negative 1?
X plus 3 and x minus 4.
Beautiful. So I'm going to factor this into x plus 3 and x minus 4. Now I need to solve them. So I set each factor equal to 0. Subtract 3. X equals negative 3. And x equals positive 4. Okay, these are going to be the numbers that are going to break up my number line into my intervals. Now, they've got it here, but let me go ahead and show you over here to the side. So if I draw my number line, over here I have negative infinity positive infinity, and then I'm going to put the two numbers that I just found by solving the inequality or the equation. Now, step number 3 is to check for a test point. Now, technically, I don't need to check a number in each one of these sections. If I pick 0, again, my pattern is going to be this. In each interval, I'm either going to give it a check or an X. And this pattern will repeat. So if I start with a check, then it's an X, a check, an X. Or if I start with an X, the next one would be a check. So now I'm going to take my original equation. X squared minus X minus 12 is less than 0. Notice when I solved the quadratic equation, I did not get 0 as a solution. So I can plug in 0 for X, and if it works, then the section where 0 would occur, so again, remember, this is your number line. So like here would be -2, -1, 0, 1, 2, 3, all the way up to 4. Yes?
Did we ever flip the equality symbol?
If, we'll get there.
Okay.
Okay, so I'm going to plug in 0. 0 squared. 0 squared minus 0 minus 12 less than 0. -12 less than 0. Is this true or false? It's true. So the section in my intervals that where the 0 is gets a check mark. Then these other two intervals get X's. So now my answer in interval notation, because the only thing that would make this inequality true are the numbers right here in this section. So again, notice your beginning problem was just a less than. So my answer here is just the segment -3, 4, and they have parentheses. Now, we're going to see in the next example where we're going to bring in the union symbol, where it's not going to be the middle, it's going to be the two outside pieces. Here's the graph down at the bottom. So if I were to graph this on a number line, again, it was broken apart, the two solutions I found. And again, the answers, it gets a parentheses, and it's in between, because this is where the check mark was. Let's try the next one where the outer parts are going to be the solutions. So again, step number 1, I'm going to change the inequality symbol to an equal sign, and I'm going to factor this. So I'm going to change the problem into 2x squared plus 5x minus 12 equals 0. I'm looking for the factors of -12 or -24 that give me 5. Now I can either do this guess and test, or I can do it with factor by grouping. So if I just guess and test, my factors are 2. I'm going to put a 2x here. I'm going to put an x here. And now my factors of -12 that I'm going to try, it's either going to be -1 and +12, -2 and +6, or -3 and +4. It's actually going to be -3, +4. So if you're going to do the guess and test method, at this point you would FOIL this and make sure it goes back. Now again, if you're not good at guessing and testing, then you do the factor by grouping. But what I highly recommend you do is after you think you have the two binomials, you need to FOIL it and double check it. All right, so now that I've factored it, now I set each one equal to 0. These are going to be the numbers that I'm going to break my number line into to create the intervals. 2x equals 3, divide by 2. X is equal to 3/2. Over here, subtract 4. X equals -4. Okay, now my next step is to break up my number line. Again, -infinity, +infinity. I'm going to put the numbers on the number line logically least to greatest. So the -4 goes here. and the 3/2 goes here. All right, so next I want to do a test point. Again, the easiest point to check is going to be the 0. I did not get 0 when I factored it. So now let me take my original problem, which is the 2x squared plus 5x minus 12 greater than or equal to 0. Every place that I see x, I'm plugging in 0. So 2 times 0 squared plus 5 times 0 minus 12 greater than or equal to 0. I end up with negative 12 greater than or equal to 0. Is this a true statement? No. This is false. So the area in my interval where 0 occurs, which is going to be right in here, gets an x. Again, remember the pattern, it stays an x a check, an x a check. So if the middle is crossed out, then the two ends get the check marks. Now, you can actually pull a number from each interval, but the fastest way to do it is just to pick one test point and know that the pattern always works. Everybody with me on that? Okay, so now I need to write my answer in interval notation. And I'm going to read my graph from left to right. So my graph here, if I were to graph this, using how they are going to show it in the textbook, they're going to show it's got a bracket. So let me redraw this. So it would be from here going this way and from here going this way. So the way that I'm going to write my answer in interval notation is I'm going to represent this left side, and this is going to be from negative infinity up to the negative 4. I'm going to union that because I want to include both pieces. And then over here, from 3/2 to positive infinity. And that would be your answer in interval notation. So when the middle fails, it's going to be a union, and you would write the less than side, and you're going to union that with the greater than side. Yes?
When we use the upside down,
We wouldn't be doing that for these. These are going to be the union. But just in case you see it on the PSAT, and if they ask you to, write your answer as, I guess it's sort of like a compound thing where it's the things that are in common.
Okay.
All right, everybody good on this one? Let's try another one. Again, let's change it to an equal sign. X squared minus 7x plus 10 equals 0. I am looking for the factors of positive 10 that will give me negative 7. Those factors are going to be x minus 5 and x minus 2. Again, set each factor equal to 0. Solve for x. X equals 5. Add 2. X equals 2. Now, again, let's break up so we can see our intervals, so we can see where the 0 is going to be. Again, put them in here, least to greatest. And you can see that 0 this time isn't in the middle, because if you were to add numbers here, this is 1, this is 0. So my 0 is over here. So after I plug in the 0, if I get a true statement, then I put a check mark in that first side. So let's try and plug it in. So x squared minus 7x plus 10 less than or equal to, greater than or equal to 0. Original problem. 0 squared, negative 7 times 0 plus 10. I get 10 greater than 0. Is this true or false? It's true. So the section on my number line where the 0 occurs is this first one. Then the next interval section where it's broken apart gets an X. Then the last one gets a check. And again, you're going to write your answer in interval notation as you read it from left to right. So in interval notation, you would say, for this part right here, it's going from negative infinity up to the 2. It was just a greater than symbol, so they both sides get parentheses. Then this middle part, it's the X, so I don't include it. I'm now going to union that with this half. So then this becomes 5 to infinity, and they both get parentheses. Again, if you're going to check it with the textbook as far as the graph goes, 2 and 5, it would be a parenthesis going that way and a parenthesis going that way. Again, set it up as an equal sign. Again, I'm going to guess and test. So my factors of 3, I'm just going to put a 3x here, an x here. Factors of 4 are either going to be positive 4 and negative 1, or negative 2, positive 2. But the one that works is going to be the positive 4 and the negative 1. Again, you can guess and test or factor by grouping. When the numbers are like this, I think it's a lot quicker just to guess and test. All right, so now set each of the binomials equal to 0. We need to find out where we're going to break our intervals up. Divide by 3. X is equal to negative 4/3. And x is equal to positive 1. So again, let's see. Here's my number line. Negative infinity, positive infinity. Again, you're putting your two solutions least to greatest. So I'm writing the negative 4/3 first. You can see that 0 is going to be located in this middle part. So again, I'm going to plug in 0 because I did not get 0 as a solution. So 3 times 0 squared plus 0 minus 4, negative 4 less than or equal to 0. True or false? Okay, so the middle part gets a check mark. The two things on either side get the X. So now my interval notation, my answer here is just going to be bracket, bracket, connect it. So negative 4/3, comma 1, and it's a bracket on both sides. So when it's the middle section, it's the two numbers you got when you solve the quadratic, and then make sure you're putting the appropriate symbol, either a bracket or parentheses. Try the next. Okay, for this one, I need to turn it into a quadratic equation, so I need to distribute. So I would distribute the x to the x and the x to the 1. So this will become x squared plus x less than 12. I'm now going to move the 12 over and change it to an equal sign. Factors in negative 12, that give me positive 1. And that's going to be x plus 4 and x minus 3. Set each of the factors equal to 0. Subtract. X is equal to negative 4. X is equal to positive 3. Again, let's put them, break our number line up. Negative 4, positive 3. Let's do our test point. 0 is located right in here. So I'm going to take my original problem. X times x plus 1 less than 12. 0 times 0 plus 1. I get 0 is less than 12, which is true. So my middle, again, gets the check mark. The two intervals on the either side get the x's. So again, my interval notation, because it's just a less than, I put negative 4 and 3 in parentheses. And again, if you were to see the graph, parentheses, and connect it. Let me turn this to an equal sign. So x squared equals 16. Now, I don't care how you solve this one. You can either just square root it, or you could move the 16 over and then factor it, or square root both sides. Just remember that when you use this square root method, you get plus and minus 4. So now when I go ahead and set up my number line, so same thing here, x equals -4, x equals +4, -4, +4, negative infinity, positive infinity. Again, my 0 is going to be located in this section. So when I plug in 0, 0 squared, is 0 squared greater than 16? No, it's not, right? This is false. So this gets an x, and then the 2 check marks are on either side. So again, we're going to write it compoundly with the u. So over here, this is going to be the parentheses going this way. So this will be negative infinity up to -4, unioned with this side. And this would be from 4 to positive infinity, both parentheses. Pretty good on that one? All right, the next one. Again, when we go to solve this one, it can't be factored. So when you encounter something like this, you either need to use completing the square or quadratic formula. Now, on the test, you're going to have completing square questions. So I'm going to use this one. I'm going to solve it with completing the square just so you can refresh the technique. Now, on the test for the inequality part, though, you can use quadratic formula. You will get one separate question where you're going to have to use completing the square. Okay, so just be aware of that. All right, let's try to solve this one. I'm going to add 1. I need to set it and make it an equal sign. Now, there are no factors of 1 that will give me 4, so now I have to do quadratic formula or completing the square. I'm going to complete the square just to refresh your memory. So again, remember, for completing the square, we move the constant. We take the b term, divide it by 2, and square it. So what we're adding to both sides is 2 squared, which is 4. So then now I factor this side. So this becomes x plus 2 squared. 1 plus 4 is 5. And now I apply the square root method. So now I would square root, and I did something wrong. It should be a -1. Okay, this is a -1, so that's a 3. Okay, let's see. Here we go. So now, when I square root the 3, I get plus and minus square root 3, and then the x plus 2. I need to subtract the 2. So x is equal to -2 plus and minus the square root of 3. So now I need to put this on my number line. So I'm putting -2 minus the square root of 3 and -2 plus the square root of 3. Now, I have to figure out where is my 0 located. So I need to approximate the square root of 3. All right, so if you think about it, your perfect squares are like 1 squared, 2 squared. 1 squared is 1. And then the next one, well, we can just do it right here. So I know that the square root of 3 is going to be less than 2. Okay, it's approximately about 1.7. So I can already see that this number, if I'm doing negative 2 minus 1.7, this is going to give me a negative number. Same thing here. If I know that the square root of 3 is less than 2, then I can still see here, even when I'm adding something less than 2, this number is still negative. So you're going to have to approximate where your 0 is located. So 0 is actually going to be located over here in this last section. So again, now the process is the same. Take your 0, plug it back into the original, x squared plus 4x greater than negative 1, 0 squared, 4 times 0. 0, is that greater than negative 1? Yes, it is. So this gets a check mark. This gets an X. This gets a check mark. Again, you got to repeat the pattern. Check, X, check. So now my interval notation is going to be this piece over here. And it was a greater than, so it's a parenthesis. So from negative infinity up to negative 2 minus the square root of 3, unioned with negative 2 plus square root 3, comma, infinity. And over here, this would be here. What this U represents is we're taking the far left side, the less than part of it, and we're putting it together with the far right side, which is the greater than. Because again, remember, when you square root a number, we have to take into consideration both the positive and the negative number. So that's why I have 2 pieces to my answer here. All right, so homework is 157 to 158, those pages 39 through 51. This is due on Thursday because tomorrow's the PSAT. So after you go home, eat your lunch, take a break, do your math homework unless you have time to get it done today. All right.